People. Sup. Today I'm using the phone webcam because I just wanted to show you guys something. Let me just show you guys something. Oh, look at it. Look at it. Oh, come on. How do you zoom out? Oh no. There you go. Look at it. That's St. John's. Yeah, just go back. So that there was St. John's and it was raining. It was raining. Yes, I said where I live, right? Oh my God. I literally said where I live. Oh, like as if nobody knew where I live. So we're gonna do MATLAB today. Um, we're gonna do for 1 hour. Then I have work. Then I got work again. Just yeah. So I'm using MATLAB because I have my school account. And using my school account, I use my MATLAB. So I'm going to use MATLAB based on the MATLAB I have. I'm going to try to understand everything from here. And what I will also do is time to time, I am also going, actually, I need to also download MATLAB, right? So download, actually, did I download MATLAB? Again, it won't be like a full course because today is Saturday and I mean, there are no buses, so I technically have to walk 3 hours and then come back uh, tomorrow morning. But Uh, we're still doing MATLAB. So my plan is that every Saturday, like whenever the days that hit Saturday, I'm gonna do MATLAB on those. Let me just download it actually. The only reason I'm using my phone is because today is raining, so why not? And yeah, I'm not using any filters or whatever. So let me see if it's actually live streaming. Oh, right, okay. We are live. We are live, right? Are we live? Are we live? Are we live? Are we live? Yeah, we're live. So this will be MATLAB programming. Okay, create a dashboard. Oh, since when did I have 4 followers? That's so weird. MATLAB programming. X and MATLAB. Did we download? Yeah. Again, I'm just trying. Oh, okay. I'll not focus much because I've done a little bit of MATLAB. Uh, okay, I do have. Oh, um, boom. Yeah, sorry, I have to. Again, this won't be like a full um serious stream. Oof. You need 26.88 gigabytes. How much storage do I have? Okay, so I need to free up quite a lot. I don't know what, how much, what's other? I don't know what's other. Only 1.75 gigabytes is gone. What's temporary file? Okay, what's other? What's installed? I don't have that much, honestly. Like I don't even have that much. Like to think of it, like I don't have that much. Um, no, it's fine. Like you see, like I don't have that much storage that I'm going to occupy. I think it's the other that I need the Visual Studio Code. I need it. That's the thing. I'm not going to uninstall. Mictex I need it because that's my latex code. NVIDIA, people, Prism Lens I need it. RStudio. I need RStudio. VMware, I don't need VMware. Okay, I can't even uninstall it. But okay. And yeah, I mean that's it. By the time, let's do the. Oh my god, why is the resolution so bad? What the I prefer it to be light switched off. Okay, that's bad. Oh, come on. Yeah. I don't know. The resolution is. Just switch off. Just give me 2 seconds. Let me just switch off and then switch on again. And then close that. Open the browser. All right, are we good now? Okay, is lagging a bit. Okay, I think it's something to do with the light or whatever. Let me just switch on the light. Yeah, no. Yeah, I'm not entirely sure. The maybe it's something to do with I don't know why is the resolution so bad. Anyways, I'm just going to stop here then and use my own. Yes, I use green screen. Mm, yeah, this is better. This is way better. At least for now, this is way better. Yeah, switching on light now. I don't know if I don't even care if I look good or not because I don't want to switch on the light. Because if I switch on the lights, like oh,
When you start MATLAB, the default layout contains 3 panels: the Command window, Workspace panel, and Files panel. In the Command window, you can enter MATLAB
let me see if
commands
I
and their
let me see if they have online MATLAB compiler. Online MATLAB compiler. For now, I'm just going to use this. I'm going to use this for now. I'm going to use the my compiler for now, and then once it installs, then I'm just going to use the actual MATLAB.
executed.
So let me just copy this. Any core stuff to know? I mean, I've done okay.
You can organize all your commands and their output together in a live script.
I think um, commands is done. Okay, vectors and matrices. There, that's where we have to begin. That's where we have to begin. Vectors and matrices. Because obviously this is like 106 tutorials from all the way from beginning to end. So yeah, how would you let's just um use the actual let this install, don't worry. Don't worry about it. Let's just let this install. Okay, so what is an array? All MATLAB variables are arrays. So each numeric variable can contain multiple numbers. You can use you can so each numeric so you can store related data in one variable using an array. Because array is a basic programming tool in MATLAB, it's important to get to know them and terminology to use them. All right. So manually enter the arrays. What am I supposed to write? X is equal to 4. X is equal to 4. Do I click enter? Do I click submit? Okay. And then task two, you can create an array. So it will be x is equal to, oh, come on. So x is equal to 3, 5. Or does it have to be 3, comma 5? No, it is 3, 5. Oh, what? Fuck. Y is equal to 3, 5. Yeah, I did. 3 and 5. Oh, come on. It's 7 and 9. Oh, for fucking God, man. So when you separate numbers using the spaces shown in the previous task, MATLAB contains the numbers into the previous task. Oh shit, I have a book. What the fuck am I doing? What the fuck am I doing? I have a book, man. I have a full book. Dude, I got a fucking book, man. Why am I going for this? I have a book, man. Look at it. I have a fucking book. Do you see what can I do? I can read a book for one. I have a book, man. All right. Acknowledgements and all the Kalman filtering. The page. This is what? Let me just. Yeah. So page 28. Let this install. It's going to take time, and by then, oh, use snipping tool. And nope, I'm learning from DeepSeek. Can you explain? So this is MATLAB, and can you explain like slowly what's going on and stuff? We'll try our best to do 1.1 today. Oh yeah, we need the iPad because there's a lot of math. How many chapters are there for? We'll try to do 1.1, 1.2, and 1.3. So 1.1, 1.2, and 1.3. Quite a lot of maths, quite a lot of maths. No, we're not going to touch 1.4. So in the based on this abstract, is it possible to slowly explain each image one by one? So one image, explain the thoroughly. Let me understand what's going on, what is going on. The maths, like the maths and the programming with MATLAB. Once I understand, then move to the next one. Move to the next one. All right, so okay, slow down, slow down. Oh shit. Okay, can you hear me? Let me see if they can hear me. Can you hear me? Let me see if they can. All right, slow down, slow down, calm down. Where's DeepSeek? What the fuck is going on? So the key idea is recording, receding the horizontal contours. So plan for the future, but only act on the immediate next step. Do like less English. Explain. So explain less English, more mathematics, and the only English I want to see is the core explanation and do it step by step. Actually, you know what? Um, Let me see if ChatGPT can do it. I mean, they can because unlike DeepSeek, like ChatGPT does understand like what I want, so I don't have to over explain it. Oh shit! Can you explain this? Can you explain these images step by step, one step at a time? So what is the problem trying to solve? So your rocket guidance apparatus says the rocket is flying, wind changes, the mass changes because the fuel will burn, the aerodynamic force changes, the rocket will start drifting away from the desired trajectory. It's not rocket, we're focusing on hypersonic missiles. We are focusing on hypersonic missiles, not rocket. So imagine a hypersonic missile traveling at Mach 5. And at those speeds, tiny errors are huge misses. So, for example, you have the wind gusts, you have the air density change, you have the shockwave effects, you have the thrust variations, you have the sensor noise, whatever. And the mass reduction from fuel burn can push all the missile away from the desired path. So imagine a hypersonic missile traveling at Mach 5. So at those speeds, tiny errors are huge misses. So for example, you can have wind gusts, you can have the air density change, you can have the shockwave effects, you can have the thrust variations, you can have the sensor noise. These can push the missiles away from the desired path because you see that people when you have like little changes, like this is a hypersonic missile you're talking about. It's not some random. Let me just So there's not some random. Oh God, what, what am I missing? What? Okay, no. So okay, on a hypersonic missile, you have like even if you have little changes, it's bad. The core problem. Suppose the missile is trying to hit a target. So at time now, so at your current time, like at your current time step, not time, but at your current time step. When did we start? Okay, probably like 20 minutes. So at the current time step, the missile will know its because it has a sensor, right? And so the missile will know its current position, its current velocity, the altitude, the angular rates, and whatever. But the target is still far away. So the missile must decide what fin deflection should I apply right now, and that decision must be done within 100 milliseconds. A traditional controller often works like measure error, correct the error, measure error, correct error, measure error, correct error. But you don't know what happens in between. So what happens is that only time there's going to be movement of like fins, or the only time we're going to have like a change in anything. Let's say, for example, they got the error, and then like the only time we're going to have a thrust calculation is if after all the error correction is done. But there is no model that even in the middle of doing the error, you still do the changes. It doesn't exist because when you look at it, like when you look at the missiles, when you look at the rocket, it does do its launch, it does do its thrust, it does do its push, all that, whatever. However, the thing is, it does because you have programmed that already. Like you didn't, like, it will not do the change. It will do the changes in the middle. I'm not saying it doesn't do the change, but the only reason it does the changes in the middle is because you programmed it to make sure because it's like saying you got the maths, you did the maths, you did all the calculations and stuff like that, and then you said that at that specific altitude, then you're going to separate the rocket, then you're going to separate this, then you're going to change the thrust and whatever. That is why at that time step it does its. This is what, when you look at the radio, right? It's like, okay, um, starship separation, or you're gonna say fin deflected. You'll hear that, see that, right? Because they know that at what time step it should work. Because although you see that it's correct, it's going well, it's going so well, you see that, right? But like behind the scenes, the math, the engineering is like very difficult to do that, right? MPC kind of. So the MPC will think ahead. So instead of asking where am I, it asks if I move my fence 2 degrees to the right, where will I be 1 second later? So it doesn't like, yes, it depends on the person who's doing the programming, sure, but it also, at the same time, it's also like, okay, um, if I move my fin 2 degrees, where will I be? Then if I move my fin 3 degrees, where will I be? Then if I don't move my fin at all, where will I be? So every single second, think of it like the not only the person trying to program all the time, but the missile is also trying to estimate, okay, what will happen to me? What will happen to me? So you have like two humans. One human is controlling, the other human is flying. So what's the book's plan explain is, so the okay, so 9 a.m. to 5 p.m. planning. So you have a current time. So you predict the next zero point 0.1 second, and predict the next 0.2 second, predict what happens on the next 0.3, and so on and so on and so forth. Which means your DT is actually zero point 0.1. Your adaptive guidance paper, okay, fine. All right, where does the maths begin? Where does the mathematics begin? Then let's begin with the mathematics. Let's begin with section 1.2, but let's bring in the knowledge from section 1.1 into 1.2, and let's learn the maths. Okay, I think the only reason I wasn't able to download it is because I only needed two things actually. I don't need the entire thing. And if I look at you need like you need to uninstall almost everything. I don't even have that much. Yeah, I don't even have that much to even. I mean, I need Microsoft Visual Studio Code. So I'm going to quickly. Mm, we're going to quickly hide it. Let's see. Get an image, a random image. Sorry. Yep. Yep. Next, we're gonna have three products, not two. Let's see if that works. Okay, then let's not use that. If I add, oh shit, then let's add MATLAB and say, okay, what? What? And let's add MATLAB. There you go. Let's add MATLAB then. I'm going to download Simulink later. Uh, yeah, I'm just going to download Simulink later. I'm not going to focus on Simulink at the moment. Anyways, so section one, okay. So the very first equation in section 1.2.1, where is 1.2.1? 1.2.1. So single input, single output system. So that there. So x of m k plus 1 is equal to a of m x of m k plus b of m u k. So that's we did that right in the first chapter. Okay, so this book has it. Nice. Y of k is equal to c of m x of m k, where u is the manipulated variable or input variable, y is the process output, and x of m is a state variable vector with assumed dimension n of 1. Note that this plant model has u of k at its input as its input. Thus, we need to change the model to suit our design purpose in which an integrator is embedded. Note that a general formulation of state space model has a direct term from the input signal u of k to the output y of k, as y of k is equal to c of m x of m k plus d of m u of k. However, due to the principles of receding horizontal control, where current information of the plant is required, we have implicitly assumed the input cannot affect the output. What does it tell us? So we learned that the current state, the current state, then predict the future, and then you go to optimize the future, and then apply the control, and then it goes back again. Then immediately a problem will appear. How can we predict the future if we don't have mathematical description of the missile? Now we need an AI model, and this is what 1.2 explains. The symbol x of mk is called the state vector. For a hypersonic missile, a simplified state vector could be h, v, theta, or q, where h is the altitude, v is the velocity, theta is the pitch angle, and q is the pitch rate. Okay, suppose at this instant the missile height is 25,000, the velocity is 1800 meter per second, the pitch angle is 5 degrees, pitch rate is 0.2. This tells us that the altitude is 25 kilometers, velocity is 1800 meter per second, pitch angle is 5 degrees, pitch rate is 0.2 rad per second. Let's do that example actually. Um, so this will be MATLAB with math. How do I? This is MATLAB program. MATLAB lesson one with math. All right. So let's say, for example, you have that the x of mk. So you have the example one. So suppose you have xm of k. That's a state vector. So you have 25,000. You have 1800. You have 5 degrees and 0.2. So obviously 25,000 is the altitude. So this is the h altitude. This is the v, which is the velocity. You don't write speed. You don't mention speed because speed is a scalar quantity. This is the pitch angle, theta, and this is the uh, q, pitch rate. So the book writes that u of k. So for a hypersonic missile, the u of k could be del f, where del f is a fin deflection. The u of k is the steering, right? U of k is more of like a steering change, and Um, the steering change differs depending on what vehicle you're using. So, for example, if you have a car, the steering change would be the steering wheel itself. For a rocket, it would be fin. For a missile, it would be fin. Let's say, for example, if you have an airplane, then it's going to be wings. Fin too, like not the tail, like the I don't know if you call that fin or if you call that tail, but even that controls it. And you also have little fins just all the way behind the engine, but the the if you have a plane, you have that also controls it. You don't see it, but that's inside that fin. You see that it's like those flaps, and they're gonna rotate. So it's if it wants to move to your left, then it's gonna do like that. If it wants to move to the right, it's gonna move like that, right? But they also have fins like right behind the engine, like we know where the engine is. Inside that there's a fin. So second mathematical output. So obviously U of k is the del f, where del f is the fin deflection. So for example, U of k is 2 degrees, meaning they move the fins by 2 degrees. The third mathematical output, the book writes that y of k is c of m x of m k, meaning what do we care about? For example, you care about the altitude, you care about the pitch, because y of k is the function space. People think I'm Valentina. Wait, give me 2 seconds. This people actually think I am Valentina. What? Nah, you gotta be joking. People actually think I'm Valentina. What? What? Nah, nah. They actually think I'm Valentina, so they're like, your credentials are nothing when you act like an uneducated, hateful, racist thug. You have zero credibility and full of, what the fuck did I do? And then it's best you and Dweeb ass brother go hide so people forget about you. Then you can start over somewhere else. Don't they actually think I'm Valentina? Nah, nah. This dumbass actually thinks I'm Valentina. Dumbass actually thinks I am Valentina. You know what? What do I say? What would Valentina think? What would Valentina think? Just give me 2 seconds. What would Valentina think? Come on. Wait, I am smarter than you. I am better than you. I am more knowledgeable than you. I stood where you never stood. Where you never stood. I worked my ass off and became the best. I am narcissist. I am the best. Look around you. How pathetic. Look around you. Have a blind eye. Oh, fuck, man. What? 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 What mistake did I do? No, what mistake did I do? What? What? Oh, come on. I can't even say pathetic. What? Nah, that's nuts. So to the new viewer who came, people think that I'm actually Valentina. Like, I don't even look like Valentina, but I don't know why do they say I'm Valentina. So I just presume that I'm Valentina, and then I said I'm smarter than you. Oh no, 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 no. Did I make a mistake? Nah, I didn't. Fuck you. Fuck you. I didn't. Anyways, back to work. Boom, boom. Anyways, so third mathematical output, the book writes y of k is equal to c of m x of mk, right? And output means what do we care about? So we care about the altitude, we care about the pitch angle, we care about the cross track error, whatever. The book will write ax of k plus bu of k. I did this, you did this, I taught you guys this. What does this mean? This fucking means this A here is a matrix. This matrix has some values x, y, z that's going to control your height, that's going to control your velocity, that's going to control your pitch angle, that's going to control your pitch rate. Now, this matrix is different from the matrix for B. B matrix is in correlation to the steering. So it's like saying you're going to move um, zero point 0.3 degrees to the left, 0.3 degrees to the right, zero point 0.3 degrees. So let's say, for example, you have X, Y, and Z, right? Because if you look at the steering, it's going to move X, Y, and Z. And the matrix for B is based on, okay, so you're going to move zero point 0.3 degrees in the X direction, zero point 0.3 degrees in the Y direction, zero point 0.3 degrees in the Z direction. So it's kind of like that. But A is more of like you have a matrix and based on, so these consider that A matrix is like a correction matrix, right? So consider the A matrix as a correction matrix. So we're going to have some values and we're going to input those values into our state vector. We're going to multiply those state vectors and we get a more optimal value. So let's say, for example, initially, the xm of k, let's say it's at 25,000, 1800, 5 degrees, and zero point 0.2. Let's say. So if I, how many people are there? Oh, one person. Okay, no worries. So let's say, for example, I have 25,000, 1800, 5 degrees, and zero point 0.2. And let's say that I have height and I want to like lower down my height because I have to reach the target, right? And so if you want to reach the target, one thing you have to do is you have to first go high and then you have to come down lower, right? So let's say then on the next zero point 0.2 second time step, you want to go higher. And so you're going to have a matrix that's actually going to have a higher value but a more optimized value because you don't want to go too high. It's actually going to easily miss the target. You need a certain altitude. So what it's going to do is that matrix is going to be calculated, gives you the output, multiplies by this state vector here, and then it's going to do all the arrangements. So now let's say it's going to go from 25,000 to, let's say, I don't know, 25,300. So it's going to go 300 meters more. Maybe let's say that's the best output. And 25,600, and then let's say you want to lower it down, so your A matrix must be a little bit lower, A matrix must be a little bit lower again, and you're not going to have one value, you're going to have three values because it's a 3 by 3 usually it's a 3 by 3 matrix because they focus in correlation to X, Y, and Z, right? Hypersonic missiles, so yeah. If I move the fin 2 degrees, where will the missile go? So let's say, for example, you want to move the missile fin by 2 degrees, then what happens to your altitude also? Not only where will the missile go, but what happens to your altitude and what happens to your velocity also. Let's do the MATLAB program if that's all right. Yeah, I understood. So without this equation, the core equation is actually x of m. Can we do uh can we do one example? Can we do one example? Well, for what you just explained. You just explained. Can we do one example? So x m of k is the altitude and one control input. We have one control input, that's a fin command. To keep the math simple, let's pretend that the missile follows that x of x m of k plus 5 u of k. Again, b is not a value, b is a matrix, but again, for simplicity. The next one I'm going to use like an actual real life value. So current simulation at this instant we have x of k, x m of k is 100. So meaning we are only focusing on altitude here. Usually you're going to have altitude, velocity, pitch, angle, and pitch rate. But here, because we have one value, we're going to presume that that is altitude if it's not mentioned. So let's say altitude is 100 units. So the controller will choose u of k is 2. So meaning the fin command. Let's say the steering so the steering, the u of k, the steering thrust change, you're going to connect that to the fins of those missiles, and then you're going to say, okay, so the initial fin command will be set to 2 degrees. So I'm going to move the fin. Initially, I'm going to move the fin 2 degrees. Predict one step ahead. So substituting the so isn't it like Euler equation? Isn't it like Euler? I think it's like Euler, right? Why does it familiarize with Euler equation? Or maybe I'm wrong. Maybe I can be wrong here. Yeah, it does correlate with Euler. Yeah, x dot is a of x plus b of u. X is the missile state, u is the fin command. Can you give me one more example, this time in correlation to the abstract? Less English, more mathematics. So suppose the missile state is 1300. So altitude is 1000 meters. So I'm just going to follow this example. So suppose you have x of k is equal to 1300. So 1000 will be height in meters and 300 is the velocity. So the current state, h will be 1000, v will be 300. And suppose a is 1, 0.10, and 1. Again, the only reason a will be a matrix, usually it's a 3 by 3 matrix because you do x, y, and z. But for the sake of this example, because there's only two matrix, which is 100, 1000, and 300, so we are going to focus on a 2 by 2 matrix. I mean, you can do 3 by 3, but it's not necessary. So let's say we have height is 1000 meters and 300 meter per second is the velocity, right? And so my A will be 1, 0.1, 0, and 1. So that's A, the matrix for A. So state vector matrix. And B will be 0 and 5. The fin thrust command U of K is 2. Now one question. One question. How do you know what the matrix will be? One question. Here we are already stating what the matrix will be. Matrix will be. In real life, it won't work like that. How will the matrix be calculated? Yeah, I know, obviously. Missile pitch dynamics. What is missile pitch dynamics? Oh my god, you have that? Suppose the missile pitch dynamics are I inertia of y q dot will be m, where I of y is the moment of inertia, q is the pitch rate, m is the pitching moment. Aerodynamics tells us that M, the pitch moment, will be the M alpha of alpha plus M Q of Q plus M delta of delta. Now we have a differential equation. And now define the states. X is alpha and Q. And after rearranging it, we have X dot will be AX plus BU, where A and B naturally appear from physics. Okay, I still don't understand this, but okay, slowly. Okay, wait, slowly, slow down, slow down. I still don't understand what you're saying. What are you saying? No, I know that, but then you just explain about the. Oh, come on, I understood this. Yes. No, I understood, but what my question is, so okay, if I oh they explain the equation, that is why that's what I'm not understanding. So okay, let us just see the so what are they explaining here? So because I'm trying to understand what's going on here. I'm seriously trying to understand what in the fucking world is going on here. Okay, what is going on here? Oh, come on. Okay, what is going on here? What is going on here? Okay, whatever you see, whatever images you see, whatever you see, is it possible to explain thoroughly using examples and MATLAB programming? Because I don't know, like for some reason it just went directly somewhere else and somewhere else. So the book starts with okay, so what does it start with? X of m k plus 1 is a of m x of m k plus b of m u of k, and y of k is c of m x of m k. The original statement. So x of m k plus 1 will be a of m x of m k plus b of m u of k. Okay, so this is the general equation to find the next step, like the next time step, or the next movement step, or the next infinitesimal step. So x of m k plus 1 will be a of m x of m k plus b of m u of k. And y of k will be equivalent to c of m x of m k. Now suppose a very simple missile model. So a of m will be 1, b of m will be 2. Okay, fine. Simple model because usually a of m is in the matrix format. So this is like a 1 by 1 matrix. So a of m will be 1. So this is 1 by 1 matrix. And b of m will be 2, a 1 by 1 matrix. And so I'm going to have, therefore, x of m, k plus 1 will be x of m k plus 2u of k. Which means I'm not going to change the fin control. So the fin control, not the fin control. Yeah, the fin control, like not the fin control, the missile control. The missile control will stay as is, like the same altitude, the same velocity, the same whatever. Like whatever allows the missile to move, then will stay as is. And the control input for steering, like what needs to be changed, let's say for example the fin command. So in missile, the best thing like you need like to control the missile, like you need to have fins, right? And the fins are the only reason why it either goes up or goes down. Yes, there's thrust, obviously there's thrust, but you must understand thrust alone can only push, but it cannot move. But the only reason you're moving is because it has fins in it. And think of fins as being the steering for missiles, and so that will be u of k. X of k is more of like a static, like the only thing it can do is like push, right? That is the only thing it can do. So what are the things that it can change, but it's not going to change the direction? Let's say thrust. Thrust can increase the power, but it's not going to change your direction. And let's say altitude is going to increase your height, but again, it's not going to control the pitch up, pitch down. It's not going to do that. The only reason you have this pitch up, pitch down is because you have u of k in it. If you don't have u of k, so it's kind of like, and then if you want to go up, it won't be able to go up, because even if it wants to go up like that, you still need fins for that. So technically, it's not. It won't be able to go up. So this calculation won't exist. Maybe it can. Can it? No, it can't. It can, because then it's going to move like that. But if it wants to, let's say for example, land, this landing, right? This landing, like considering this landing, right? That landing is done by fins. But if it doesn't have fins, it's going to be like weep. And if it wants to land, weep. So like obviously, even planes have fins. Even though they land like that, even planes have fins, because at the end of the day, planes also, how do they launch up? They don't launch up like whoosh, right? So they go on a runway and then they don't launch like that. It's not like it's bouncing, obviously. Let's do, okay, installation complete, good. Then we can use MATLAB, right? All right. Okay. Okay. I think something is definitely wrong. If I write MATLAB, okay. Yeah, move. Okay, anyway, so we have a is equal to 1, b is equal to 2, x of k is 10, u of k is 3. So you have xk of 1, so the next time step will be a of ax of k plus bu of k. A is 1, b is 2, you substitute them. So you're going to have x of xk of 1 being 16, because why? A is 1, x of k is 10, so 10 times 1 is 10, and then 3 times 2 is 6, so 10 plus 6 equals 16. What MPC doesn't like, so obviously I'm just going to use this example. Can you write the MATLAB code for now? So I'm going to have a is equal to 1. Okay. Yep. All right. So I have a is equal to, I'm writing the current location, right? B is equal to 2. X of k will be 10. So x of k will be 10. U of k will be 3. Let's say x of t will be a times x of k plus b times u of k, 16. All right, it works. What MPC doesn't like, so let's say for example, x of mk is 1000 and the next one is 1005 and then 1008. They don't care about that. So they care about how much it changes. So they want, so MPC will only care about what's the difference between the two values rather than what is the value right now. They don't care about what's the value right now. It can be any value. Doesn't matter. What matters to them is how much has it changed. Difference variable. So the book defines xm of k being xm of k. So the derivative, like the difference in correlation to the um, state vector for the missile will be the current state vector minus the previous state vector. So for example, if xm of k is 105 and the previous state is 100, then 105 minus 100 is equal to 5. I can do that. So we're going to write error state will be x of, oh wait, I need to find another one then. Um, this let's say x of s is 10. Let's say the previous one is 10, right? So x error will be x of t minus x of s. Okay. No, we just presumed again. We just presumed. We just presumed. So this increased by 6. So here in this case, the state increased by 6. So for example, if the previous fin command u of k minus 1 is 2 and the current fin command u of k is 5, then u of del u of k would be 5 minus 2, which is 3. Now the controller changed the fin command by 3. So we can do that. So let's say, for example, I'm going to say u1 will be 15 and u2 will be 30, not 30. No, no, that's too much. That's too much. 19. So fin error would be 19 minus 15 is 4. So the fin angle has increased by 4 degrees. Pretty simple. Yeah. So why are they doing this? Because MPC will only care about the difference in values. They don't care about the current values. You have a different sensor that actually cares about the current values. MPC doesn't care about the current values. MPC will only care about the change in values. So then MPC will ask, how much should I change how much should I change the fin angle? This will give a smoother control. The key equation that they're going to derive is x. Actually, when is the where's my phone? Actually, let me just quickly check when is the okay. So the next key equation they're going to derive. So after some algebra, the book will get x of m, xm of k plus 1 would be a of m del x of mk plus b of m del u of k. So this is exactly the same state model as before, except now everything is expressed in changes. Let's do an example. Let's do an authentic example in correlation to this. Let's do two examples thoroughly, very less English, more math derivations that correlates to what you just explained. The wind gust disturbance. So state x of k is e of k, and where e of k is a cross track error. Suppose that a of m is 1, and so the model x of k plus 1 would be x of k plus 2 u of k. Now the current state x of k is equal to 10, so which means the wind gust missile by plus 3, and therefore we're going to have the next one as 13. Pushes the missile by 3 meters more. So the current position is 13. The controller command is minus 2, so which means x of k plus 1 would be 13 plus 2 minus 2. Controller commands fin angle has lowered down by 2 degrees. So 13 minus 4 is equal to 9. So the next prediction, choose that u of k plus 1 is equal to minus 2. Then k plus 2 would be 9 minus 2. K plus 3 would be 5 minus 2. I mean 5 minus 4, and then so on and so on and so on and so forth. Yeah. Now, if I were to wait. If I were to begin building it right. Can we use this knowledge to building, begin programming what I want to build right now? Let's go then. But then okay, I won't be knowing the matrices, right? That's the problem. I don't know, like, I know that matrices will not be given during the operation because, like, you don't even know what's going to happen. You don't even know. How do we calculate the matrix? Suppose we know the Newton's second law F is equal to ma. For a missile, is 100. I can see there is 100, 1000, and thrust is 5000 newtons, and the drag force is 2000 newtons. So 10,000 v dot would be 50,000 minus 30,000. So the acceleration is 30. And so the velocity will increase at 30 per meter second. 30 meters per second. Velocity increases by 30. Acceleration is 30 per meter per second. My God. So choose the state vector. X is equal to v, then x dot is equal to 30 because we know that x dot is equal to 30. X dot is what? Wait, you don't make sense. Why would x dot be 30 when you're. How is x dot? How is velocity 30 when acceleration is 30? Okay, I'm very confused. I am extremely confused. I am extremely confused. I don't know what's going on. What are you saying, or what are you trying to explain? Trying to explain. I don't understand shit. I don't understand shit. What are you saying? Okay, I guessed it. So, so suppose every second we measure the vehicle speed. So at t equals 0, you're going to have 100, and then 110, 121, 133.1. So you can write the equation is that. So suppose now in a matrix form, suppose we have altitude and no, I understood that. I understood that. Wait, I understood that. But why? Okay, from what you just explained about the matrices and whatever, but what you just explained about finding the matrices and whatever, you're not explaining that clearly. You're not explaining that clearly. Why? I don't understand. Why are you not explaining that clearly? Oh, he skipped many things. Okay, he's skipping a lot. No, again, okay, no. Here, hmm, yeah, yeah. The matrix values will not be known. The matrix values will not be known during the operation. Uh, if you are aware of it, if you are aware of it. So my question is, how do you know the matrix values? And even though we don't know what the matrix value will be, like, again, I'm not sure. Like, I'm positive he's. Yeah, let's not. Okay, the book assumes, but we don't want to assume. So the mass are changing, Mach number is changing, the air density is changing, temperature is changing, because that this is considering that everything is constant. We don't want that. Sensors will measure the height, the velocity, the pitch rate, the pitch angle, the angle of attack, the pitch angle of attack, the acceleration, the x-axis, and the acceleration is z-axis. So then an estimator says, based on what I measured, I think the current dynamics looks like this. The estimated matrix is that. Cool. And then the estimated matrix will change. Then the estimated matrix will change. Yeah, it is going to change. Yeah, but how do we... There. Oh, okay. So that is later. So for now, let's okay, can you write the entire code, like what's going on and stuff? Just yeah, just write the entire code. I just want to know like what's going on and stuff. Like I just want to know like what's going on and stuff. All right. Let's just yeah. If we have the code, let's just you know what? Let's just begin with the code. Begin with programming. Like let's do it. Let's do it. I want to see. I want to see how much I understood. Right? Let's begin. Let's begin with the programming one. I mean, I have done those, all those, which to create. Okay, I have the new MATLAB script. Actually, I'm going to write clear and CLC. Clear CLC. A is 1.1, X is 100. So for K is equal to 1 to 2. Oh, so that's how you write the for loop. So A is equal to 1.1, X is equal to 100. Or do you have to put a semicolon? Okay. I don't see myself putting a semicolon, but okay. For K, 1 to 10. Oh, sorry. How do you do that? X is equal to A times X and F print F. So that's how I print F print F. Okay. F. Okay. No. Oh, you can't go back again. F. Oh God, you can't go back again. Wait, you can. No. There's no way you can't go back again. No way you can't go back again. So you can't erase on MATLAB. Oh no. What? Wait. How to erase a line on MATLAB? Yeah, I mean erase a text on MATLAB. I don't see erase option here. Oh, you have to use a full function. God. Okay, you know what? Uh, clear CLC. Oh God. No, 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 no. Oh man, I'm just gonna God fucking damn it. Uh, let's go for a new script. Yeah, I'm just going to. Can I like? Is there any way to delete this? No. Wait, you can't delete this? Oh crap! Clear C. Oh God, you actually can't delete that. So you not only so you have to be very careful on how you code. Right. So A is equal to. I didn't knew that. I seriously didn't knew that. So A is equal to okay. Clear CLC. A is equal to 1.1. Okay. Why? Okay. How to erase. So like I wrote the code here. So I wrote the code. Oh, come on. So I wrote the code and I'm trying to erase the code. I did write clear CLC, but it still doesn't work. I don't think you can erase it. At least as far as I know, I don't think you can erase it. Oh, but it doesn't even run now. Let's save this as desktop MATLAB code 1. A is equal to 10. Yeah, it doesn't even work now. Let's say B is equal to 5. Then X is equal to 8 times display X. Yeah, run. Run the code. What? Run the code. Oh, you don't. Okay, you won't run the code. So it's like one-time use. Am I right? Okay, script. Let's see. A is equal to. Okay, so it's a one-time code. So one time. Okay, so it's a one-time use. No. So I um clicked a new script, but it doesn't run the code even though I am trying to run the code. So it's kind of like useless now. Surely there's got to be a way. He won't find it, so I am going to find it. No, he won't understand. So, oh my fucking god. Anyways, thank you for your help. Thank you for your help. God, man, you can't even help. There is no run. Look, wait, okay, where do you see run? Let's see. Run. Do I see run here? Hmm. It's like Dora the Explorer, right? So I am do right. Run. Yeah. Run. Show me the code. Oh my. Okay. Run. Mhm. All right. Um. Let's write the code again. So where is it? Let's say a is equal to 1.1, x is equal to 100, for k equals 110. Yeah, I'm right. X is equal to 8 and I know, I know. And then f print f, you write step percentage d percentage dot to f and k and x. K x. And should it be a double quotation mark? No. End. Now let's run the section and let's run the section. So it keeps on outputting 100, 100, 100, 100, 100, 100. Did I make a mistake? I Surely I wrote. Hmm. Why does it only print 100? Am I making a mistake here? I don't know if if I made a mistake or not, but I keep getting 100, 100, 100, 100, 100. So oh, okay. Is that no? I keep getting 100, 100, 100, 100, 100. Oh, okay. My bad. X. Now let's run this section. Okay, now I get 100 and 100 and 100 and 100 and okay. I think the only reason I'm seeing 110, I know. I know what's going on. T is equal to hmm, hmm, x plus equals no wait. X is equal to I I know why. I know okay. I know what's going on because it's gonna be like 110, 110, 100, but I need to add with something, right? Should I know that this is going on a loop, and I also know that it's also going to be like 110, 110, 110, 110. I know why it is 110, 110, 110, 110, 110. But meaning I have to add with what do I have to add with? Oh, x is equal to x plus ax. No, I know. X is equal to x plus into. So I'm going to write t is equal to x plus. So you have like 100, right? And then 110. Okay, am I making a mistake or am I not making a mistake? Because I'm so confused. I believe I'm making a mistake, but what is the mistake? I don't have to add with something. I'm already multiplying it, right? Why do I have to add with something? It never changes. That I know. I'm going to change this code here. Okay, the only reason it's not changing is because I'm using a. I think it should work now. No, it didn't. Nope, it didn't. Actually, let me. Nope, this here. Let's try that. Oh, they don't do that. X is equal to x plus ax. Now what's the error? Now I'm still getting 110. Okay, no, I'm still getting 110. I don't know what's going on. I'm still getting 110. I don't know what's going on. I don't know what's going on. So I also added, but I still get 110. Okay, what is going on? Okay, let's try this exact code here. I'm going to try this exact code. I'm going to go to MATLAB, write this exact code, run the section. Now it's fucking working. Why did it fucking work now? Why now? Okay, why did it work why did it work when you code? So weird. Okay, never mind. Anyways, all those maths and whatever, I see that you haven't explained the maths yet. I see that you're trying to complicate things a lot. I don't know why, but can you just explain like what is going on? It's not meant to be easy, and the examples that you give is also very easy, which doesn't, which is not very productive. The difference in the book explanation and yours are different in a way that yours is too easy. Like you don't want to teach. Like the book is very difficult. I can see that, but you're not explaining that. You aren't explaining that. Anyway, I don't even have that much time. It's like a wasted time. Okay, so what's going on? Okay, then explain the book. Explain the book. Explain the book. Explain the book, please. Please. I don't have time. So the original plan is that the book starts with x of m is equal to k x of m k plus 1. So we know that. So we know that. So x of m k plus 1 is equal to a of m x of m k plus b of m u of k. And y of k is equal to c of m x of m k. And the interpretation is that x of m is the internal state, u is the control input, y is the control output. And for a hypersonic missile, x of m is the velocity, the pitch rate, altitude, whatever. And u is the fin command, y is the quantity we care about. So we have x of m k plus 1 being a of m x of m k plus b of m u of k. And y of m is c of m x of m k. X of m being the... I have to go anyways. Anyways, bye.